So this is our 13th lecture of STAT291, and we are going to talk about linear regression with categorical predictors in here. That means we will have some categorical variables as an explanatory variable. And please remember, the response variable is still continuous in this concept. Okay, and so let me continue with the with the first slides of this topic. We have K as 2, which is the most basic case in this type of regression. And so it is possible for us to use discrete or categorical explanatory variable. And we may have K distinct groups or levels. And we may want to model our mean responses in here. And so please suppose, first of all, that you have a predictor as categorical. And as a first step, maybe we will think that we have a binary variable in here. That means K equals 2. And your observations are going to be coded like 0 or 1. So is there an example comes to your mind that can be a categorical variable? Do you have any example?
Female and male.
Excuse
like
me?
The gender.
Gender may be a good example for binary in this concept. And so, but there is something different than the classical regression with continuous variable, as we have seen last week. And this time, the interpretation of your model parameters are different. Okay, so both of your beta 0 and beta 1 can be think as intercepts in here. And so it is better to think of them as something like 2 intercepts, like beta 0 provides the baseline or reference value of the response when x equals 0. And beta 1 represents the additive effect on the mean response when x equals 1 in here, okay?
Professor,
yep.
Are you sharing your screen? Like, because we are in slide 1, right? Is it correct?
We are in PowerPoint slide 1.
Okay, I thought we are in 2, so okay.
So I'm here. Can you see our studio comes up and go?
No.
No. Just see the slides.
Yes. We just see STAT291 Lecture 13. Linear regression. Yeah, that's. I thought you were talking about something else. So yeah.
No. Can you see it now?
Yeah.
Yes. Yeah.
Okay. Now we are good to go. Sorry, guys. So this time we are going to use a categorical variable in here. I already talked about this part. And now we don't have slope in here. You can think them as 2 beta 0 and beta 1 are as 2 intercepts in here. So how we can do our interpretation in here is that, so it's better to think of them as being something like 2 intercepts, okay? Your beta 0 provides the baseline or reference value of the response when your x equals to 0. And beta 1 represents the additive effect on the mean response if your x equals 1. So what happens in here is that if your x equals 0, then y equals beta 0 and epsilon. Okay, you see that one?
Yeah.
Okie dokie. So we have x equals 0 and our equation is going to be like that. And if your x equals 1, then your equation is going to be like this one, okay? Because please remember we had beta 0 plus beta 1 x. So if x is 0, then it just goes away. And if it is 1, then you have beta 0 and beta 1 and epsilon as your regression line in here. That's why we have a different interpretation in these kinds of regression. Do you have any questions?
I have.
Okay.
Does it only apply in simple linear regression, or it can be used in multiple linear regression?
Yeah, of course, we can also use with multiple regression and with different types of regression models, not just the simple one.
Okay.
We can use them in anywhere, okay? So let's see how we can apply these models in R. Okay. Let's move to R together. Maybe you may want to open your R with me, guys. And I'm going to use, of course, R Studio in here. And
I'm
yes,
sorry for interrupting.
sure.
I
No
just
problem.
want to ask, is the audio not like fully clear only to me or like to everyone so that I can edit my audio settings?
I can
Guys,
hear
can you hear me
I can
well?
hear the teacher.
I
I
think
can hear
there's no
her, I can
problem.
hear the professor, but it's not as high as like the earlier lectures for some reason.
Maybe it's your internet.
I'll check it out. Right.
Can you volume up? Can you do that? Is it?
Sorry?
Can you do your volume up? Like increase the volume?
I
or-
have it as full.
Oh my God.
Yeah, that's why.
Yeah, it's maybe about your, or can you just log out and log in one more time maybe?
I'll try playing with the settings. Thank
Sure.
you for answering.
Okay, sure. May I continue? Is it okay for you, Ahmad?
Sure, Professor.
Okay, so we will go back to the survey example as we have seen before. And maybe you may want to remember this data set. It is an embed data set in R. Oh, where was that? Which library we use? MES?
MES.
Yeah, MES library we use. Sorry, I said that it's embedded in here. Maybe you remember that this data set were used for the data frame. It contains the response of 237 statistics students at University of Adelaide. And they're just looking for the gender, written hand span, and span of non-writing hand, or which hand are you using there, and the fold. They tell you to fold your arms, and they just record which is on top, and pulse rate of students. And then they ask you clap your hand and just record which one of your hands are on top. And so exercise, smoke, height of the student in centimeters, or if the student is smoker. It has 4 categories in here: heavy, regular, occasionally, or never. And we have age and we have MI variables in here. For today, since we are working on the categorical predictors, we may want to use one of them. So as a starter, let's start with binary one. So let's check out for the one which can be binary. And I want to ask for the first one. So maybe you can see in your output there, it's a factor. That's what we are looking for. And for a detailed information, we may check out a table of this variable, and you will see the frequencies for both levels, and they're equal size. Interesting. Okay. So maybe you remember that after we check out for descriptive statistics as a first step of our analysis in here, we may want to see if there's any differences between these two groups in terms of one of the variables that may be height, for example. And so we are looking for some visual evidence for that one. So what should we do as a first step to see if there is any differences between these two groups in terms of height? What do you want me to do? Huh? Plot.
We might have some visual plots.
Yes, we may use some plots in here. And as a very clever programming language, R knows which one to use in here. If you just write plot, and I'm going to use survey data width height versus, you can just use tilde in here. And again, one of the categorical variables. And when you check out for this one, you will see a box plot. R knows which one to use. And so we just define or specified the response variable to the left, this guy, and which is numeric. And we also define the exponential variable to the right, which is a factor, okay? So the default behavior of R in that situation is to produce that box plots in here. You may see that box plots, and maybe you notice something in here. What can it be? What is this?
Outlier.
Yes, it's an outlier in the female. We have one outlier there. And can you see any differences between these guys?
Males are generally longer.
Yeah, they are longer.
Height-wise.
There may be some differences between these two factors.
Also, the skewness is not the same. One is like almost normally distributed, and one is right. Is it right or left? Yeah, like one is skewed.
Yeah, one of them is skewed, and one of them is kind of symmetric in here. So do you remember what was this line? What it shows?
The mean, the
median. Yes.
Median, yes. In box plot, it gives you the median as the central bold line in here. And if you want to see your points on your plot, you can just add points. That's easy. And then you have your survey height in this example versus, we just should write as numeric to get these points in here. You can just give other options. Now we are able to see all the points on our box plots in here. And maybe you remember that we were using least squares as an estimation method for our regression. So least squares use mean as an outcome. So maybe it can be useful for us to use mean or to show means and try to get some idea if there's any differences between them, just looking for that mean in here. There are several ways you can add your means on your box plot, and I will use one of them. Let's just find the mean for this gender. And I can use tapply function in here for the vector of my height variable. And the index is going to be gender. And my function is just mean, okay? I'm going to get the mean for each gender. And maybe there should be some NA values, and please remove them for me. True. And we have now means for these two factors, and you will see that they are kind of different than each other. And now we can have the same plot, and we may want to add some points this time. And like here, we have the same plot. Let's get this guy. And I want to add these means on my box plot, okay? Because least squares is using means. And again, the points in here is going to be what? Means that this sex variable and 4 and 3, just try more. And you will see that now we have signed our mean values on our box plot. So what does plot indicates for you guys? What it shows to you? You said that before. We are just
so as we can see here, the mean and the median of the female group are like almost like are approximately close, like very close. So we can consider it as, you know, normally distributed. But the difference between the mean and median in the male group is a bit larger, greater, we can say.
Yep.
And also we can see that the range for the male height is longer than the range for the female height.
Mm-hmm.
And the interquartile range is also bigger for the male than the female's height.
Mm-hmm.
And we have one outlier.
Yeah, perfect.
Yeah.
This is
Yeah,
all
and also I can say something else. As we see in the male group, you know, in the what, the whisker in the bottom, it has very few observations than the one in the top.
Yeah, that's why it's cute in here, maybe.
Yeah.
So depending on the comments, Lekadit, we can say that males tends to be taller than females. And also we can just check for if we can get any statistical evidence for that one. Okay, we are looking for a statistical evidence, and let's use some linear models as before. And we are going to give a name to our model in here, survey fit 2. And here is my linear model. I'm going to use height versus gender. And my data is survey. Here is my model. If I just write summary and the name of my model in here, I'm going to find some more information. And now you will see that we have some estimations this time. And so this is my beta 0, the estimate of my beta 0, okay? So this is the estimate of the mean height if a student is female. Because maybe you can see that this is just saying sex male. That means your female is your reference in here, okay? So if your x0 is 0, or if your x is 0, then you will just get beta 0. And you can just say that, and the beta 0 in here, the estimation is the estimate of the mean height if a student is female, okay? So the corresponding regression coefficient for the male is 13.13, okay? And that is the estimated difference that is imparted the mean height of a student if male. So if male, you can just expect that these differences would be happen overall, okay? Did you get the idea in here?
Yeah, we did.
Okay.
Yeah.
That was easy. That was easy. So also we can do some predictions, okay, this time. For the predictions, as you may remember, we were generating some toy data. And let's say I want to get some extra observations. And I'm going to generate them as factors in here. Let's say I have female, male. This is my toy example data. And again, male, and again, female. Here is my data. And I want to check out for my extra observations, which are just factors with 5 values. You may see them. So if you want to do your predictions in here, just use predict function ready in R, and we will just use our survey fit model, which is a linear model, and our new data is going to be what?
Extra observation.
Extra observation, but please remember that it has to be data frame, okay? And it has the same name as the original data in here. And here is my extra observations in here. And we want to get the interval of confidence. I mean, the confidence interval in here. And you can just determine the level depending on your project, okay? And here are my predictions in here. I have, maybe you can recognize that this time you have same for these two guys, and you have same estimations for your parameter and your confidence interval for males and females, okay? You can just do your predictions kind of straightforward in here.
What does it predict actually? Like you are giving a factor.
Yes.
And does it predict the likelihood of that factor being the next observations?
No, is it just estimating the mean height value for these observations? For example, if there's a female, and most probably it is predicted height, the mean height is going to be 165. Okay, and if it is male, it's going to be the mean value can be 178 in here.
Okay.
Okay, perfect. So I'm going to continue with multi-level variables. What does it mean? We will have k, which is greater than 2 in here instead of 2, okay? So we will continue with that one. Let me stop share. And so this time, we are, instead of 2 variables, we will have more than 2, I mean the 2 categories, we will have more than 2 categories in here, okay? For this process, it's good to recode or generate dummy variables to create several binary variables from a categorical variable in here, okay? So instead of the single categorical variable with possible realization, I said in here, such as 1 to k, we will just recode it into several yes-no variables, okay? Let's see what I am talking about. So for the first variable, you will have 0 and 1s, and 0 and 1s, and 0 and 1s for all of them, okay? And for example, for the first one, you have 1 if it is x1 and 0 for the rest of them. This is called dummy variables in here. And so generally we use k-1 dummy binary variables. It's because we have one reference variable or baseline level in here. And so we will end up the model, the estimated model, something like that. We have y hat, beta 0, beta 1, beta 2, and beta k-1, okay? We have beta hat k-1 because one of our variables are the level, the baseline level or the reference in here. And so, for example, when we are talking about this model in here, if your observation x3 is 1 and all other binary values are therefore 0, okay? So maybe when you just think about one categorical variables, your x is going to be 3 in here, but since you have binaries in this concept, so your predicted mean value of the response would be something like this one. You have beta 0. This is for the reference line. If you don't have any of them, you only have beta 0. But in this example, we have x3 as 1. So you will get the estimation corresponding to x0, which is beta 2 hat, okay? This is my predicted mean value of the response in here. And let's move to our studio and just apply this one in an example, okay? So in survey data, maybe you remember that smoke variable describes in here. We have smoke variable in here. You may see that. It's just giving you the kind of smoker of each student, okay? They can be heavy smoker, never, occasional, or regular smoker in here. And so we should be careful that we have two options. We should check it out before go on. Sorry, guys. And the categorical variable of your interest should be stored as a factor. And you should check that you are happy with the category assigned as the reference line. So maybe when we are talking about this one, let's see, we want to check out if it's a factor in here. I want to say my survey smoke. Here is the variable I want to use. Yes, it's a factor. I'm good to go in here. I should show you the result. I'm good to go. And let's say their frequencies in the data. I want to see the frequencies of each category in here. And we have 11 heavy smoker and never smokers and occasional and regular smokers in here, okay? And if you want to see the levels of your variable in here, again, for your smoke data, and you see that we have all these levels, okay? First of all, what we were looking at, if we have any evidence to support a difference in mean student height according to smoking frequency in here. Let's first just add a box plot. I can use just box plot in here with height versus smoke. Oh my God. And my data this time is a survey. And when you just check out for this one in here, you will see that I have this box plot for each of my category in here, and I want to add all my points on that. 1 to 4 and T apply and survey height. Yes. And I have survey dot smoke, and I want to get mean values because I'm going to add them on my map, on my plot. And please remove if there is any NA values in here. And what did I do? What's A in here? You see that now I can see the mean values for each of my categories in smoke variable. And I'm not sure if we can get any differences between these 4 categories because they are kind of close to each other. You see that one. And if you want to generate a new model, let's say I have my new model as named as 3. And again, we are using linear model, height versus smoke this time. And oh my God, my data is survey.
Hocam smoke yanlış yazdınız.
Evet ya. Thank you. Okie dokie. Now, when you ask for the summary for your model, the third model, and you will see that you have your intercept, which is the baseline and the reference line. Can you guess which one is your reference line for this variable? Which is your reference variable, reference category in here? Which one is your reference?
Smoke never.
No.
The one that is not here.
Yes, the one that is not in here, which is?
Never, occasional, regular, heavy.
Yes,
yeah.
heavy. We don't have heavy as...
Do we take it all 0 since it is reference?
Yes,
Zero.
Yeah, it's the reference value and the corresponding estimate is the intercept for this one, okay?
Okay.
And what does it mean is that if you are heavy smoker, the mean value of your height can be 173.77, okay?
But like, I have a question. So
Sure.
like, people who smoke regularly are somehow taller than everyone else. Like, it doesn't. I like.
Why
yeah.
don't you say the opposite?
Yeah, if you
Yeah, like, but like,
taller people seems to smoke heavily.
yeah.
it doesn't
Actually
make sense to me.
we don't have any statistical evidence, because maybe when you just check out your p-values, it says that this variable is not related to
Yeah,
your
they're bigger
height.
than
Okay?
Yeah.
So, but still, yes, if you are a heavy smoker, then you are going to be taller than the ones never or occasional smokers, but shorter
Let's
than the
smoke,
regular.
guys.
That's interesting, but we don't get that. And maybe when you check out for R square values, they are really low, and this model doesn't make sense that much, okay? And then
Yeah.
the p-values also are greater than your alpha value, then it's also saying that you don't have any evidence there. But we get some estimates of coefficients and corresponding to our dummy binary variables, and for 3 of your 4 possible categories in this example, okay?
Okay.
So heavy is your reference, and it's just represented by beta 0, okay? And other coefficients provide the effect associated with this observation in one of the other categories in here. And also you can find some point estimates throughout the prediction. Even your model doesn't make sense in here, statistical I mean. And let's say one of each. I want to generate my own data, and I will estimate for these data sets through my model in here. Let's get your survey.smoke, all of them, okay? One of each. You have all of them in here. Now you want to do your prediction for all of them. I have my survey fit 3, my last model, and my new data is what?
Data frame of one of
yes, data frame of one of each, and we should get the same name for this data set. And let me just do like that. And I want to get also the interval of confidence interval, I mean. And let's get level as 0.90 or 95. And here are my predictions, guys. You may see the fit values and the confidence intervals, and they're kind of close to each other in here for all of your 4 categories. Maybe when you just check out for the heavy one, which was our reference, you will get beta 0, and you will get the exact one for beta 0 in here, okay? And a student in the occasion category is predicted to have a mean height of 173.7772 minus 0 point something. What was that? 0.74, and you will just get this guy 173.0287. Okay. So, but still, please remember, when we are looking for the output of our model, and none of the binary dummy variable coefficients are considered in here statistically significant, okay? And we also have small R squared value, and the variation in the response cannot be explained by changing the category of smoking frequency in here, okay? And if you can find one of the categories are statistically significant, it would imply that the smoking factor as defined here does have a statistically detectable effect on the response, okay? And if you want to change your reference, do you remember which one was our reference? In here was heavy. You can always change this reference category for your analysis in here. Let's see which one I want to get. Let's smoke reordered, and I want to re-level my variables. Survey.smoke. And my reference this time is never. Generally, we try to use that one as a reference. And now when you check out for your smoke reordered, yes, this guy. And this time my never is going to be my reference, okay? And please try to remember that linear model impose dummy coding only if the exponential variable is an unordered factor vector in here, okay? So when you just run your model one more time, this guy, with your new data set, smoke reordered, you will see that this time you are going to get height not How can we run this model? Do you have any idea with this new level?
What?
If you want to change the never as a reference line, I think I may have to add this variable in my data.
I guess I need to practice this part a lot more because I don't know why I feel a tiny bit confused, like between everything that's happening. We're like adding new terminology every 2 seconds and like re-level. Like,
Okay, now so by reordering your variable, okay, and you will see that now your reference is now never, and you will get your variables. And as a reference line, you have your never in here. This is going to be your mean height if you never smoke. And these are the differences if you smoke. Yeah, you are taller than the never smoker. But still, your p-value is really high, then it doesn't make sense, okay? I mean, it makes sense, your model makes sense, but not statistically significant to explain the variation in height with your categories of smoke. And of course,
I mean, I don't think height and smoke is related.
Of course it is not. This is just an example, and you are not expecting to have this relationship actually. Okay? So in some cases, we can treat our categorical variable as numeric, okay? In this part, we use them as factors, but we can use them as numeric variables. And actually, we can use them as continuous variable, okay? But sometimes it's much better to do some predictions by getting them as numeric variables in here. And for this, let me give you a title in here to make sure we are going through to a new topic. We will treat categorical variable as numeric. I do that sometimes when I'm modeling my data. Generally, I treat categorical variable as numeric, okay? And we will use these empty cars before we used at empty cars. This is the data sets we are going to use. We have MPG, cycle, blah, 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 okay? And I want to see some box plots. for this data set for empty cars dot what? MPG versus empty cars dot cycle. And my X lab, I know cycle is cylinder, I guess. Cylinders. And my Y lab is just MPG. When I have my box plot, you may see that you may have 4, 6, or 8 cylinders. And this is defined as categorical data, but I may use it as numeric, okay? It's not a big harm if I just use it as numeric variable instead of categorical data in here. And here is my new model. I want to use again linear model by MPG versus cylinder. And then my data is empty cars. This is a very common used data set. I'm even fed up with this data set. Okay. And now you will see that you used your cylinder as your numeric variable. And now your MPG can change depending on your cylinder, the mean value. And it just statistically significance in here, okay? So you can say that by looking at this guy in here, the estimation of your predictor parameter, for each single additional cylinder, the model says your mileage will decrease by 2.88 mpg on average, okay? And for this kind of example, it is not a big harm that you can treat your categorical variable as numeric. For example, when you plot your empty cars mpg by your empty cars, again for your cylinder in here, and your X lab and Y lab are the same. Let's use this guy. And I want to add a ebb line in here to see my regression line. So let's see. And we have this negative relationship between cylinders and MPG in here, okay? And sometimes we do that on purpose to fit categorical or discrete predictors as continuous. So there are two advantages in here. One of them, you could use this model to evaluate the average MPG for example, 5-cylinder. You can just write 5 and just do predictions in there. And also you have fewer parameters that is requiring your estimation. So if it was categorical data variable, I mean, you will use k-1 intercepts. That means you will have 2 more parameters. I mean, one is going to be when you compare with this continuous case. And you need only 1 parameter for the slope if you just treat that as numeric in here, okay? But there is one disadvantage. You no longer get group-specific information, okay? You cannot compare groups, but you can just check out for the mean value of your MPG. So let me put it in another words. If you use your cylinder as categoric or discrete predictor, then you will have your group-specific information. Then you can compare these 4, 6, and 8 groups to each other and see the differences. But if you treat your cylinders as numeric, then you can have some idea about the mean value of your MPG, okay? These are 2 different ways of looking at your model. You can just see them in different way, okay?
Yeah.
Okay.
That makes sense.
That makes sense.
Yeah.
So of course you can always fit your model to behave your variable as categorical in here. Let's say I want to update my car fit linear model again with MPG versus what? You can just say factor to your cylinder variable and your data as empty cars. And when you write the summary of your car fit, you can always get your estimations for each category. You see that the mean, the MPG is going to be 26.66 for MPG. And if you move to 6 and your MPG is down 6.9, okay? And instead of 4, if you use 8, your cylinder is 8, then it's going to move 11 points in here. Did you get the idea, guys?
Yeah.
This is important for us. Okay, perfect. Sometimes you had some confusions, especially Ahmed told me he had some confusions, but it's going to be much clearer when you have some more practice in here. And it's kind of enjoyable, I guess, and very useful. Okay?
Yeah.
So thank you for listening. And I think I'm done with this lecture for today. And I want to talk about